Hey everyone, welcome to this lecture. Here in this particular concept, we will talk about uh, the DNS and NTP overview. So we learn about what is DNS and what is NTP at a very high level overview, and then we'll consider, taking those into the configuration aspect of Palo Alto firewalls, um, and yeah. So let's go ahead and start. What is the concept of DNS, right? So DNS, as we know, it is called as a domain naming system, right? So let me grab the pen. Yeah. So the DNS, as the name says, it stands for domain naming system. So it is kind of a decentralized naming system that usually translates any human readable domain names like google.com, for example. So to sum it up, is www.google.com. So any human readable domain names into IP addresses, right? So it will translate any human readable domain names into IP address, which might looks like this 192.168.9.10, something like that. Okay, so that computers generally it is used. So the DNS systems is generally used by your local computers to identify each other on this network. So it works like a phone book for the internet, which enables users to access any websites without memorizing any numerical IP address values. Okay, so I will draw some blocks here, and then we will discuss regarding how the DNS process works. So let's say that we have got a user. Just a second. So let's say we have got a user over here. Okay, and I have got something called as a DNS resolver block here. I have got certain other blocks called as root server. I will have a top level domain server, and I'll have an authoritative name server. Okay, so yeah, let me just try to draw certain analogies out of it. So this indicates that those are basically my servers as an example. All right, so also I will have another block over here, which will be generally be the ISP. So let's say this is my, so this piece is my web server. Okay, this is going to be my user, who is trying to browse certain website, for example www.zbnetworks.com. so it tries to browse to this particular URL, and this is the ISP, which will take the user traffic and it will route that particular user traffic. So let's say I've got a connectivity to the internet, so both my web server hosting this particular page of zbnetworks.com. so I have hosted this zbnetworks.com page over here. Okay, and this ISP has got connectivity to this particular block, which is called as the DNS, or you can say ISP DNS resolver. So I can directly say that this is my DNS resolver. Okay, this is my DNS resolver, and I'll have certain other components over here. It is called as the root server. This will be called as the NSTLD, which is name server top level domain, and this will be the authoritative name server. So when you understand the kind of concept of DNS, so remembering these blocks are also important, so make sure you memorize those concepts. Yep. All right, so how it works now. So I've got a user who is trying to browse to this particular URL called as www.zbnetworks.com, and this is the web server which is hosting the page of zbnetworks.com. Now everything is connected via internet service provider, we know, right? So first of all, what happens is when the user types a domain name into its browser, so several steps will occur to resolve this domain name into an IP address, right? So without IP address, communication cannot happen. So first thing first, the user will go and check its local cache, right? So I will just write down some key points over here. So first thing first is the device will first check if it has the IP address stored in the local cache. So checking local cache on the computer itself. Just a second. Checking the local cache on the computer, or I can say on the user computer. Okay, that's the first thing. Second thing would be if the IP is found, the process will end here. So if the IP for the requested URL, if it is found in the local cache, the further process will not be involved. Now second process would be to query the recursive resolver, which is also called as the DNS resolver, right? And it is basically ISP's own DNS server. Okay, so the second process would be to send the query, if it is not available in the local cache, to send this particular query to find out, hey, what's the IP address of zbnetworks.com to the ISP's recursive resolver. So you can say querying the ISP DNS resolver, also known as recursive resolver. Okay, now if the local cache does not have the information, as I've told you, so the request will go to a recursive resolver. So usually it is provided by your ISP. The resolver will check its own cache. If it finds the IP, then it will return it to the browser. Otherwise it will proceed to the next step. Okay, so the query would now go over this ISP to this DNS recursive resolver. If in the cache of the DNS recursive resolver the IP address is found, then the respective IP address of this requested URL will be given back to the user. But if the IP address is not found, then it will go and proceed to the next step, as I've told you. So third process would be to query the root name server. Okay, so third step in the process would be to query the root name server. Query the root name server. Okay, so what happens is now this particular query would go to the DNS resolver, will send this query to this root server, or sometimes also called as root name servers. So there are 13 root name servers available in the world that manages something called as the top level domains like .com, .org, .in, .au, etc. right? So there are total 13 root servers or root name servers that is available in the world, right? That maintains those domain like .com, .org, right? .au, etc. Okay, now the query will go to this particular root server. The root server does not provide the IP address generally, okay, but it will direct the resolver to the appropriate top level domain server, or we can say TLD name server. So the root server says that, hey, you are querying for this, the request is coming for www.zbnetworks.com. okay, so I don't have the exact IP address of zbnetworks.com, but I know the TLD who can help you out. So the resolver, so the query goes to the .com name servers, as I've told you. Then the root server will provide back the DNS resolver with the information about the TLD name server, right? So now it will go and query. The next step would be to go and query the top level domain name server. So the process would be to query, one second, the process would be to query the TLD name server. Okay, so the resolver will now query this particular TLD name server, example.com TLD server, right, for zbnetworks.com. okay, so the TLD name server provides the address. It will also not have the it will query the zbnetworks.com top level domain, or the TLD, but the TLD will also not have the IP address, but it will go and provide the information about the next server who can have the information, which is called as the authoritative name server. So it provides the info of the authoritative name server, right, and the request will be made to the authoritative name server over here. So the resolver will now query the authoritative name server, which will contain the final IP address of the domain. Okay, so it will go and query. The next process would be to query the authoritative name server. Okay, so the resolver will now query this authoritative name server, which will contain the the IP address of the requested URL of zbnetworks.com, and it will go ahead and return the IP address to this particular DNS resolver, right? So let's say the IP address for this page, it is going to be, as an example, 11.12.13.14, whatever. Okay, a public IP address generally. So next job will be to return this IP address to the browser. So now when the DNS resolver receives this IP address, the next, and they can say the final job it will be to return this IP address to the browser, right? Return the IP address to the user browser. Okay, so the resolver will send the IP address back to the user device, and the browser will use this IP address which he has received to establish the connection with the web server and load the website, right? So he has got that, okay, the requested IP address is, the resolved IP address is 11.12.13.14, and the request will go to this web server which is actually hosting this IP address, right? So let's say this web server is running on 11.12.13.14. okay, and then the web page will be made presentable to this user, and the user, normally we say, it will load the web page. So the web page of that requested URL will be available to this user. All right, so yeah, what happens is, in this particular process, now the browser will cache this information. So subsequent times when the user is trying to reach the same URL, so the process will end at the user level itself, because it will have in the local cache. But if in the DNS cache the information is removed, then it might go and contact the ISP. So ISP will check its own cache. If it is available, then the entire process does not happen back. All right. Otherwise, the process repeats. Okay. So as I've told you, there are different types of DNS servers available over here. So one is your recursive resolver, as the name says, which is DNS resolver. We have root name server, we have top level domain name server, and we have got authoritative name server. So the job of this authoritative name server is basically to hold the actual IP address for a particular domain. Okay. And there are different types of DNS records that you must remember as well, might be for your interview purpose or for your examination purpose, whatever you can think of. So I can just write down certain info over here as types of DNS records. Okay, so DNS, it maintains something called as DNS records, right, which will store the domain related data. So the common types are something called as a record. So it will basically map a domain to an IPv4 address. Okay, so it is going to map a domain to IPv4 address. Now IP address can be either v4 or v6, we know that. Yeah. Similarly, we have quadruple A record. So it maps a domain to an IPv6 address, right? So it maps a domain to IPv6 address. Okay, the next record is called as CNAME record. Okay, CNAME record. So CNAME record, it is an alias of one domain to another. Okay, so it is an alias of one domain to another. Okay, another. So example could be your for example, let us say it is www.google.com as an example I'm giving. It might refer to another URL which is www.google1.com, just as an example. Okay, likewise you have other records like MX record, which is used to direct emails to a domain mail server, right? So it is basically emails, I can say directs email to a domain email server. Okay, similarly you have got other records called as TXT record. So TXT record is basically, it will store any arbitrary text data which is often used for verification and security. So you can say store text data used for verification and security. Okay, other types can be your NS record. So NS record is basically, it will specify the authoritative name server for a domain, right? So if you have in a local PC the NS record, okay, as a DNS type of record, then it will have the information about the specify the authoritative name server, right, information, right, for a particular domain, Okay, similarly you have the last but not the least is called as PTR record, or we can say pointer record. So it is used for reverse DNS lookup, which is kind of an opposite process of mapping an IP to domain name, right? So it is used for reverse DNS lookup, right? Reverse DNS lookup, which is used to perform this job of mapping IP to domain name. All right, so I think it's clear as of now, the process of DNS. So just as a quick roundabout or quick refresh. So let's say a user enters www.google.com in a browser. or might be zvnetworks.com in its browser. So the browser will check its own local cache. If it is not found in the local cache, it will query the recursive resolvers, which is ISP's DNS resolver. The resolver will contact the root server. The root server will direct it to the .com, let's say over here in the example .com TLD server. The TLD server will direct it to the authoritative name server, and the authoritative name server will provide the IP address for the requested URL, and the browser will use this IP to fetch and display the website. Okay. All right, so there are certain public DNS IPs that you must remember. Okay, so for example, public DNS providers are, one of them is for Google. So we have Google DNS, which is the IPs are 8.8.8.8, and we have got 8.4.4. okay, also we have got 4.2.2.2, right, like that. We have got Cloudflare DNS, which is also going to offer public DNS IP on 1.1.1.1, and we have OpenDNS, which is going to have an IP of 208.67.222.222 and 208.67.220.220. okay. So, and you might be asked in certain scenario that what are the common DNS issues that you might face in an organization. So your answer could be like this. So let me write down some points over here regarding common DNS issues that an user can face. It is, first one can be something called as DNS cache poisoning. All right, so basically attackers can manipulate your company's DNS server, right? So your company will have its own local DNS server, so the attackers can manipulate the company's DNS server. So think in that way, that before this user traffic could reach these ISP, right? So between the user and the ISP there will be a DNS server sitting here inside the organization, right, which will hold all those DNS information by keeping this kind of records, as I've told you, like A records, quadruple A records, CNAME records, etc. So we host this in our specific server, right? Now attackers from outside can actually run this kind of DNS cache poisoning attacks, which can manipulate this DNS cache to redirect users to some malicious website. So it might actually let us say it will try to break this A records information, whatever this DNS server is having, and it will redirect the users to reach to a fake URL or a fake IP address, right, or a ROG website. Likewise, other problems or other issues can be like DNS propagation delay. This is one of the other problem the user can face. So when DNS changes takes time to update globally, right? So if you're relying on global DNS servers, but they are updating their databases, in that case it will have slowness. So likewise, we have another problem called as slow DNS resolution. It's a typical problem where a poorly configured DNS servers can perform or offer slow browsing. Okay, and the other one could be incorrect DNS configuration. Incorrect DNS configuration, where misconfigured DNS settings can lead to the site inaccessibility. So these are the common issues that a user can face. So I hope the concept of DNS is clear. I will see you in the next lecture where we discuss regarding the concept of NTP. Thank you, and see you in the next video.